Hello my friends, here we are to talk about the quadratic formula, which is a method we can use when we are not able to factor or use our square root / reverse PEMDAS method. So we can use the quadratic formula to determine our solutions to a quadratic equation. On the top of my screen, you can see the formula. You do not need to memorize it. It will be provided for you. And you can see that in order to use the quadratic formula, the first thing we need to do is make sure that the right side of our equation is set equal to 0. So that means if we have anything on the right side, we want to make sure we move it over and get everything together on the left before we start doing the quadratic formula. And we do that same thing if we are factoring as well. Those are the two methods where we got to make sure we have one side equal to 0. Once we have them equal to 0, we're going to determine what our A, our B, and our C value is. Our A comes from the coefficient in front of x squared, which in my problem here is 3. Our B comes from the coefficient in front of x, which would be -6, not just 6. And our C value comes from the constant at the end of our problem, which in this case is +1. Once we have determined those three things, it really is all about just very carefully substituting into our equation. So we have x equals negative b, and b in our case is -6. These two negative signs are also ultimately going to create a +6. If it makes more sense to you to write it as +6 right now, that is fine. If not, I'm just going to leave it for a second as negative, which comes from the equation itself. And then my v value is -6. Plus or minus the square root of b, which is -6 squared, minus 4ac. And a is 3 and b is 1. And remember, that just means that those values are all going to get multiplied together. And then lastly, divided by 2a, and a is 3. And now just the one thing you don't want to do is go try to simplify everything at once. So let's do a little bit at a time. The denominator I can change to 6 because that's 2 times 3. And here, this -6, I'm going to change to +6. Lots of 6's in this problem. And now I'm going to simplify just a little bit at a time inside the square root. -6 squared, right? That means -6 times -6. So that's going to be +36. And then these three values, -4 times 3 times 1 is -12. So -12. And I'm going to just keep simplifying a little bit. So I still have this +6 plus or minus the square root. And 36 minus 12 is going to give me 24 all over 6. I'm going to take out this positive in front here. So now I'm really close to the end. I just want to split it up so that I can show that I have my two solutions. So basically, my two options come from this plus or minus. So I have the choice where x could equal 6 plus the square root of 24 divided by 6, or x could equal 6 minus the square root of 24 divided by 6. And you can leave it like that if you want, because 24 is not a perfect square. Or if you prefer to get a decimal approximation, sorry, I'm going to grab my calculator. We can get a decimal and see what the values are. So I'm going to do in my calculator 6 plus the square root of 24. Sorry, I'm going to go up here on my paper. So for this first one, 6 plus the square root of 24 is going to give me 10.898. And then I'm going to divide that by 6. Divided by 6. So I have one of my solutions is 1.816. And then for my other one, I'm going to do 6 minus the square root of 24. And then take that and divide it by 6. And 6 minus the square root of 24 is going to give me 1.01. And I'm going to divide that by 6. and I get x is equal to 0.183. So my two solutions to this problem are both real because my square root 24 was positive, and they're both decimals, which happens because 24 is not a perfect square. So again, sometimes folks tend to leave them like so with the radical in their answer when it's not a perfect square. Or you can just get out your calculator, 6 plus root 24, hit enter, get your answer, divide by 6. 6 minus root 24, hit enter, divide your answer by 6. And we get our two solutions of x equals 1.816 and x equals 0.183. Okay, I'm going to clear my board here and we're going to take a look at one more example where the solutions are imaginary. So I'm going to erase this. So if you need to see this for a second, you might want to pause. I'm going to zoom back so we can see our quadratic formula again. And I'm going to give us one more problem. So this time we're going to do x squared plus 6x plus 10 is equal to x plus 2. And for this problem, because we're going to use the quadratic formula, we need to make sure we have one side equals 0. So I'm going to subtract my x, and I'm going to make sure I put it underneath my x term, subtract my 2, and put that underneath my constant term. So that's going to make this side cancel out and give me 0. And now on the left side, I have x squared plus 5x plus 8 is equal to 0. Once you have one side equal to 0, remember we're going to identify. Our a is positive 1 because there's a 1 in front of the x squared. Our b is 5 and our c is 8, all positive this time. Okay. And remember, a, b, and c are just the numbers. A common mistake we see is for people to say a is x squared. Nope, a, b, and c are the coefficients or the constant for c in front of the variable. So now we're going to start writing the formula. X is equal to negative sign, b is 5, so I'm just copying from up there, plus or minus the square root of b squared, so 5 squared, minus 4, a is 1 and c is 8, all over 2a, which is 1. Again, I'm going to simplify a little bit. So I have negative 5. My denominator, I have 2, because 2 times 1. And then I'm going to simplify in here. 5 squared is 25. And then I'm going to multiply these together. So negative 4 times 1 times 8 is going to give me negative 32. So now I'm just going to give myself a little more room on my page. X equals negative 5 plus or minus. And 25 minus 32 is going to give me negative 7 all over 2. And now here is where we are going to split. So we want to make sure we show our two answers. So we have x equals negative 5 plus the square root of negative 7 divided by 2. And we have x equals negative 5 minus the square root of negative 7 divided by 2. And then very last but not least, we want to simplify this radical, right? The square root of negative 7, because we are square rooting a negative, we know our solution is going to have an I in it. And you could leave it as root 7i if you want, because the square root of 7 is a decimal. But I know some of you really like to have the decimal approximation. So the square root of 7 would be 2.65. So we have negative 5 plus 2.65i divided by 2. And we have negative 5 minus 2.65i divided by 2. And those of you who are like, where'd that 2.65 come from? I'm just going to go over here for a second. The square root of negative 7 can be broken into the square root of positive 7 times the square root of negative 1. And right, the square root of negative 1 is I. And here we could just leave it as the square root of 7, or we could put 2.65i. So that's where that 2.65 is coming from. Because we can only combine like terms, this negative 5 cannot actually be added to the I. You can't add those together. Same thing here. This negative 5 cannot be subtracted you cannot subtract 2.65i. So unlike in the last problem where we were able to get two pretty nice decimal answers, for this problem we're just going to have to leave it as our answer is -5, again, plus 2.65i divided by 2. And our other answer is -5 minus 2.65i divided by 2. Okay, there you go, friends. Hope those two examples helped. Let us know if you need anything else. Have a good day.